Hi children, this is YN Suvarnalakshmi working as School Assistant Physical Science in JPHS Kottapet, Uppal Mandal, Medchal district. Children, today in this video we are going to learn about the lens makers formula. Yes, it's a very interesting formula. This lens makers formula is used by the lens makers, which are the persons who are those who have prepared the lenses for the different eye defects of humans or the persons. So with the help of this formula, they can easily prepare the desired lenses, which are very useful for us to correct our defects. So let us see how to derive the lens makers formula. Children, first let me explain the diagram. So this is a, children, what is this lens? This is a convex lens. So in this, and this is called principal axis, and P is the optic center, and this is the one curved surface, and this is the another curved surfaces. And for this, the radius of curved surfaces R1 is the distance from the pole to the center of curvature. This is R1 and this is the R2. So R1 and R2 are the two radii of the two surfaces. And children, NA is the refractive index of the medium, first medium, when the light incident in the air. So refractive index of the first medium is NA, and the refractive index of the second medium or the refractive index of the lens is NB. So NA and NB are the refractive indexes of first and second mediums respectively. So in this diagram, P is the optic center, R1 and R2 are the two radii of the curvatures, and NA and NB are the two refractive index of the two different mediums. So when the convex lens is kept in the convex lens is kept on the principal axis, there is object which is kept at O. So here the object, from this object O, a light ray is incident, and it incident or it meets or touches the curved surface at A. Children, here let us assume that there is only one curved surface. Let us assume that there is only one curved surface. So after incident at A, it undergoes refraction and it takes the direction along AQ. So it meets the principal axis at the point Q. So the image will form at Q. So this is the object after incident at the curved surface at A, after refraction, and it meets the principal axis at Q. So the distance from P to Q is called X, and the distance from P to O is called object distance U. But it is not possible because there are two curved surfaces are there. So here if we observe carefully, there will be two times of refraction will be takes place. One is from rarer to denser and another is from denser to rarer. So when the light ray travels from rarer and it enters into the denser medium, and after that it undergoes and it deviates or it refracts and it touches the principal axis at I. Because, and consider that there is a second curved surface, and this curved surface is just like concave surfaces, and imagine Q will be the object. Q will be the object and it is treated as the object for this surface, concave surface, and I will be the image of the Q. I will be the image of the Q. So finally the exact image will form at I because of the two surfaces, two curved surfaces. So children, let me remind, the distance from the pole to the object is called object distance U, and the distance from the pole to the actual image, which is called image distance, that is V. So here in this diagram, let me explain all the terms once again. So P is the optic center, R1 and R2 are the two radii of the lens, and NA and NB are the two refractive indexes of the medium 1 and 2, and the distance from the P to I is V, that is the image distance, and the distance from P to O is the object distance U, and the distance from P to Q, when we consider only one spherical surface, then the object distance is X. So these are the letters which we have to observe very carefully. So now let us derive the lens makers formula by using this diagram. Right, children, so let us discuss about the two different incidents. The first one incident is when, let us assume only one curved surface is there. So for this we have to write the equations. So when only one curved surface is kept in two different mediums, what is the equation? So let me try it. So in the previous video we already learned about one formula, that is N2 by V minus N1 by U is equal to N2 minus N1 by R. So let us substitute all the values in the given equation. So for this incident or for this equation, let us write what is V. What is V? V is the object distance. So for the first case, if there is only one curved surface, then the object will be Q. So the distance object, the image distance from P to Q is X. So the image distance is X. And the object distance U is, that is U. Object distance is U. And what is R? R is equal to, so for this curved surface, R1 will be the radius of the curvature. And what is the N1? N1 is the refractive index of the first medium, that is Na. And N2 is equal to refractive index of the second medium, that is equal to Nb. And we before substituting these values in the given equation, we have to apply the sign convention rules. So it is a convex surface and this is the object, this is the direction of the incident line. So this distance from P to I is called the image distance, that is it is also along the line of the incident cavity. So we can treat it as P to Q. This is the image distance. So we can treat it as X as a plus. And we can treat, we are taking in the opposite direction of the image object distance, so we have to treat it as minus. And the distance from P, here we are measuring the radius of curvature first to R1 here, so it is along in the direction of the incident ray, so it is also treated as plus. So we have to apply the sign conventions rules in this. So N2, what is N2? NB by V. What is V? X. NB by X minus of, and N1, what is N1? Na by U. What is U? Minus U is equal to N2. What is N2? NB minus Na by, what is R? R is R1. So let us write in another way, NB by X minus into minus plus Na by U is equal to NB minus Na by R1. This is called the equation number 1. So this equation refers when we assume or when we consider only one spherical surface. But actually there are two types of spherical surfaces. So we have to consider in this situation also. So we have to write the same equation for this situation. So for this situation there is another curved surface and the light ray undergoes 2 times refraction. Once rarer to denser, and after that it undergoes denser to rarer. So for this we have to consider the second and the other spherical surface also. For this spherical surface, let us treat Q, which is the image of the first surface. It is treated as the object for this surface. So this is the object distance, PQ, that is the X is the object distance and PI is the image distance. So let us write the different letters for the second situation. So in this situation, when we consider the both refracted surfaces or both curved surfaces, then what is the object distance U? What is the object distance U? U is X. Because we are considering Q as the object for this surface. And what is the image distance V? V is equal to V. This is the image distance V. And what is the R? What is R means? R is equal to, for this surface, R2 is the radius of the curvature. So R here, R2. And what is N1? N1. This is N1 means first the refractive index of the lens will be treated as the first medium. So N1 is equal to NB. and N2 is equal to Na. So here in this case, and the light ray undergoes from denser to rarer. In this first situation, it undergoes a refraction from rarer to denser. So by applying the given values are in this equation, and before substituting these values we have to apply the sign convention rules for every time. So for this concave surface, so the light ray is incidenting in the direction and we are also measuring the same direction. So we treat it as Q as plus and V is also plus. And what about R2? R2 we are measuring in the opposite direction of the incident ray. So we have to measure R2 as minus. So by applying these values in this given equation, N2, here N2 is what? Na. Na by, what is V? V is, what is V? V. And minus, what is N1? What is N1? It is Nb by, what is the U? Object distance is X, is equal NB. What is NB? What is NB or N2? What is N2? Na minus NB by R1. R1 is minus R2. This is the, it is the equation when the lens is kept in two different mediums, and we are considering the second situation, that is if the lens is having two curved surfaces. So Na by, this is called the second equation. So by adding these both equations, by adding both 1 and 2, we get, see, Nb by X plus Nb by X, here minus Nb by X, both will get cancelled. And what else? Na by V plus Nb by U is equal to, sorry, Na by U is equal to, here we have to take the common Nb minus Na, so then we will get 1 by R1. Here the order is reversed, so we have to take the, we have taken it as a positive, minus, so again minus into minus plus 1 by R2. And here also we can take Na as common, 1 by V plus 1 by U is equal to Nb minus Na into 1 by R1 plus 1 by R2. By dividing these equation with Na, by dividing this equation with Na, we will get Na by Na into 1 by V plus 1 by U is equal to Nb by Na minus Na by Na into 1 by R1 plus 1 by R2. So Na get cancelled, Na also get cancelled. What we'll get? We'll get we'll get 1 by V plus 1 by U is equal to Nb by Na. Nb by Na we can write it as Nba. It is the relative refractive index. So it is the refractive index of the second medium with respect to the first medium, and minus 1 into 1 by R1 plus 1 by R2. Here also we have to apply the sign convention rules for the entire two refractive surfaces of the convex lens. So in the case of a convex lens, and what is you always consider as a minus 1. And what else? V is always considered as a positive and R1 is plus. So here in the case of a convex lens, U is negative, V is positive and R1 is positive but R2 is negative, because we are measuring the distance from the opposite side of the incident ray. So by applying the sign conventions in this equation, we will get 1 by V minus 1 by U is equal to NBA minus 1 into 1 by R1 minus 1 by R2. As we know that 1 by V minus 1 by U, it is the Lense formula. So what is the value of 1 by V minus 1 by U is equal to 1 by F. we already know. So by substituting the value of 1 by f instead of 1 by v minus 1 by u, we can write 1 by f is equal to nba minus 1 into 1 by r1 minus 1 by r2. Children, observe carefully. The lens is kept in the air. So this formula is applicable only when the lens is kept in air. What is the refractive index of the air? The refractive index of the air is 1. So we can consider it as 1 by f is equal to n. This is the absolute refractive index. So because when we compare the refractive index of the lens with respect to the air, the value of the air is 1. So it becomes n minus 1 into 1 by r1 minus 1 by r2. This formula is known as lens maker's formula. And children, remember, this formula is applicable only when the lens is kept in air only, because the refractive index of the lens is only 1, and when the lens is kept in air, then we can apply this lens maker's formula to any lens. So here 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. Here f is the focal length of the lens, n is the refractive index of the lens, r1 and r2 are the two radii of the convex lens. So I hope children you understand the formula, and you also you are having how to derive. I think you learned how to derive the lens maker's formula. So in the coming videos we will learn some more important things and some more problems related to this lens maker's formula. Thank you children.